Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to cover the solubility of amphoteric metal hydroxides. Let's get into this. So as we have learned, metal hydroxides are typically insoluble. Things like magnesium hydroxide, aluminum hydroxide, those are typically insoluble or very slightly soluble in pure water. However, all of them are going to have a basic anion, the hydroxide ion, so they can become soluble in acidic solution. So if you remember, if you have an acidic solution, you're going to have low pH, and therefore the hydronium ion is going to react with the hydroxide ion that's in solution, and therefore driving more of the metal hydroxide to release more hydroxide ions to replace the ones that were lost according to Le Chatelier's principle. So here we have an example. We have our aluminum hydroxide, and if we add acid to it, the hydronium ion is going to react with the hydroxide ions in the metal hydroxide. So here the aluminum hydroxide is acting as a base, and so that'll react with the hydronium ions. We'll get 6 waters from that, and you'll have the aluminum 3+. Okay, so this is going to make it more soluble. So adding the acid will make the aluminum hydroxide more soluble. But there are also some metal hydroxides can also act as acids. So they can act as a base or an acid, and that means that they are amphoteric. So amphoteric means that a substance can act as a base in one context and an acid in a different context. So aluminum hydroxide is one of those, or aluminum is one of those as well. So aluminum hydroxide can act as an acid. So here we have our aluminum hydroxide solid. If you add more hydroxide to the solution, then the hydroxide will combine here with the aluminum, forming another complex where you have aluminum and 4 hydroxide ions bound together in this complex ion here. And so there are several metals that can act as amphoteric hydroxide. So here we have aluminum, chromium 3, zinc, lead 2, and tin 2 all can behave like amphoteric substances. Some metals that can't act as amphoteric are going to be calcium, iron 2, and iron 3. These are going to become soluble in only acidic solutions. And so if we come back to our aluminum hydroxide, we can kind of see from stage to stage, going from acidic solution to basic solution, how this comes about. So we know from previous videos that we talked about how some metal ions can act as acids because they're small but highly charged atoms. So aluminum is one of those examples where aluminum is a small but yes, highly charged ion. So it has a 3+ charge on it, so it'll form the aluminum hydroxide. So this is going to be soluble at high and low pHs, but it's insoluble at pH neutral solution. So if it's neutral pH, it won't dissolve. It'll dissolve in an acidic solution, and it'll dissolve in a basic solution, but not at pH neutral. So we can follow that along here. So this starts off as an acidic solution because the aluminum will complex with the water molecules. And so you get this ion complex here with aluminum, and you got 6 water molecules as ligands. And so because of this, one of the water molecules will tend to give off their hydrogen. So one water molecule here, or maybe several, but we'll do one here. So you have 6 water molecules. You got a water molecule here. So one of these water molecules that are bound to the aluminum is going to lose a proton or a hydrogen from the molecule. So it becomes acidic proton. And so this proton gets transferred to here, to this water. So you end up with the hydronium ion. And then you end up left over with the aluminum with 5 water molecules, and then the OH minus, the hydroxide that is left over from the water molecule that gave away one of its protons to water to form the hydronium. So this is what you got here. And so what can happen is now this, if we start to add base to it, and we're increasing the pH by adding base, now the hydroxide ion can react with the aluminum. So here I have my aluminum with five water molecules and the hydroxide. So the OH minus here can take another proton from another water molecule, right? So, and then that'll form water. So this hydroxide will take one of the hydrogens from one of these water molecules, will form the water molecule here, and then we get another OH ion here. So we get a ligand that is a hydroxide ion. So now we have 2 hydroxide ligands and 4 water ligands. Here we have 5, but now one of them became lost a proton and it became a hydroxide ligand. And so now we have water. We have aluminum with 4 water ligands and 2 hydroxide ligands. And then for the final step, we can see that this species here, the aluminum with 4 water ligands and 2 hydroxide ligands, again can react with hydroxide again. This hydroxide will take a proton or a hydrogen from one of these water molecules, and then we'll get water again, and now we'll get 3 hydroxide ligands and 3 water ligands. And this is the same as aluminum with 3 hydroxide ions, and that becomes solid. And so at this point, we have pH neutral solution, and so we have now the solid aluminum hydroxide. So you can imagine now if we continue to keep throwing base in there, the hydroxides will keep adding to the aluminum here, so just like we saw here. So we add more base. At this point, we're now adding aluminum, and we're adding more hydroxide ligands. And so this would be like with 2 waters. We're not writing the waters here, but now we have 2 waters and 4 hydroxide ligands, and we can keep adding the hydroxide ligands as we add more and more base. So you can see here how aluminum hydroxide or aluminum can be an acid or a basic. We can dissolve the aluminum in an acidic solution or a basic solution, or the aluminum, the metal hydroxide, aluminum hydroxide in a basic or acidic solution. So I hope this is helpful. If you enjoyed this video, if this helped clear things up about metal hydroxides and solubility, please go ahead and hit that like button right there and subscribe to my channel. Hit that notification button up there. Put a comment in the comment section. Let me know what you think. And if you've got any questions, I would love to hear from you. Thanks for joining me, and have a great day.